Alright, we are back. This time with byte strings. Gonna be interesting, I think. Still with all the cursed images. Alright. Lists are a cool and useful data structure. They are indeed. So far, we've used them pretty much everywhere. That is usually how it goes. There are a multitude of functions that operate on them, and Haskell's laziness allows us to exchange the for and while loop of other languages for filtering and mapping over lists. Because evaluation will only happen once it really needs to. So things like infinite lists and even infinite lists of infinite lists are no problem for us. That's why lists can also be used to represent streams, either when reading from the standard input or when reading from files. We can just open a file and read it as a string, even though it will only be accessed when the need arises. That's the idea of streams is a bit confusing to me. I mean, I'm streaming right now, but that's not it. I've seen that thrown around a bit, right? Standard input, standard output is a stream of characters. I'm assuming that's it, right? That this here is a stream that I'm doing right now. And then when I press the enter button, then it gets evaluated. Maybe? I don't know. I'm just guessing there. Don't take my word for it. I haven't really gotten around to this word, but Right. However, processing files as strings has one drawback. It tends to be slow. As you know, string is a type synonym of a list of characters. Char don't have a fixed size because it takes several bytes to represent a character from, say, Unicode. Yeah, right. UTF-8. Oh, it takes several bytes for Unicode? Didn't know that. Furthermore, lists are really lazy. They are? Cool, Get In on Tab says, I take your word for it. You sound very convincing. Do I? I didn't feel very convincing. I didn't even convince myself, right? I didn't even convince myself. Right, furthermore, lists are really lazy. If you have a list like 1, 2, 3, 4, it will be evaluated only when completely necessary. So the whole list is sort of a promise of a list. Remember that 1, 2, 3, 4 is syntactic sugar for 1 into 2 into 3 into 4 into the list. It's a linked list, right? He has never used that term, linked list, but that is something I am convinced that it is. Even though I haven't studied linked lists much before. When the first element of the list is forcibly evaluated, say by printing it, the rest of the list, 2, 3, 4, is still just a promise of a list, and so on. You can think of lists as promises that the next element will be delivered once it really has to, and along with it, the promise of the new element after it. It doesn't take a big mental leap to conclude that processing a simple list of numbers as a series of promises might not be the most efficient thing in the world. Yes. Agreed. Noteowner says, I think that you just need to practice a little every day. When you sleep, it becomes learned. Practicing too much and trying to brute force this kind of learning is unproductive at best and counterproductive at worst. Right. I'm pretty sure Noderunner is not talking about Haskell here, but about he's learning stenography, right? stenography, yeah, practice a little bit every day. Because it's, right, it's muscle memory, if you will, more than anything, right? Yeah, more than anything. Well, not necessarily muscle memory, but it's a grind. Yeah. So in a week, when you do that type of grind, it's the same like learning to play the guitar or riding a bike or whatever, stuff like that. Right. Let's say 5 minutes every day for a week. How many minutes are that? 5 times 7? 35 minutes. Alright. So 5 minutes every day or 1 hour 1 day a week. What do you think is best? It's definitely the 5 minutes every day. Even though you spend less time overall, which is probably not completely true, but it's definitely for stuff like that. Yeah, practice a little bit every day. Right, we're mostly we're mostly reading and doing theory here. I'm trying to get better at doing actual practice and doing code wars. Maybe not every day, but every other day. That's the goal right now for doing Haskell. Doing code wars every other day. Node owner says, yep. Okay, so that overhead doesn't bother us so much most of the time, but it turns out to be a liability when reading big files and manipulating them. We did some stuff where we had big files, and I was thinking the same thing. I don't know. But Haskell has byte strings. Byte strings are sort of like lists, only each element is 1 byte, or 8 bits in size. The way they handle laziness is also different. Right, they are byte size. Is this ASCII? Byte strings? Are they 8 bits? I don't know. Node owner says the same is true for Rocket League in my experience. Yeah, exactly. It's we often talk about that. There's certain types of learning, right? There are practical things that you do with your body and, yeah, muscle memory stuff. And that's not, I mean, it's not only with your body, right? Learning the multiplication table, for example, is similar like that. Yeah. Where it's a grind, right? A little bit every day. Until it sticks. That's practical stuff. Like learning a new language. Well, natural language. That's the one, right? Like learning English, learning Swedish, learning Japanese, whatever. Whatever you're learning. That thing, practice a little bit every day. Wow, there's a lot of hair here. Winter fur. And then there's more theoretical knowledge, right? More semantic stuff, right? All the theory behind Haskell that we're learning from this book. We don't read 5 sentences every day. That would be weird. Instead, we try to build a semantic structure of knowledge. Abstract knowledge. That we try to remember and internalize and understand. Usually this type of learning is more about building understanding. That makes sense? Right. Where were we? Sorry, lost track. Right. 8 bits size. Byte strings comes in 2 flavors. Strict and lazy ones. Strict byte strings reside in data.bytestring, and they do away with the laziness completely. Right, so I'm assuming that is not a linked list then. We have one array, if you will, of characters. Yeah, there are no promises involved. A strict byte string represents a series of bytes in an array. Exactly. You can't have things like infinite strict byte strings. If you evaluate the first byte of a strict byte string, you have to evaluate it whole. The upside is there is less overhead because there are no thunks, the technical term for promise. That's the first time we saw that. The thunks from this round, anatomy of the thunk leak. Right, there are no thunks, technical terms for promises. The downside is they're likely to fill up your memory faster because they are read into memory at once. Yeah, I don't have enough memory for this. For a large file. Maybe one day we'll find a large file where we run out of memory. Right. The other variety of byte strings resides in data.bytestring.lazy. They're lazy, but not quite as lazy as lists. Like we said before, there are as many thunks in a list as there are elements. That's what makes them kind of slow for some purposes. Lazy byte strings take a different approach. They are stored in chunks, not to be confused with thunks. Each chunk has a size of 64K. There we go. So we store a chunk, but we have thunks of chunks. Sometimes the naming convention in Haskell is a little bit weird. Right, but we do have... Right, we get a chunk, and then the next chunk in our lazy byte string, right? We get one byte string, and then we get a thunk of the next part of the byte string. That's what I assume, right? For very big files, we do this. So if you evaluate a byte in a lazy byte string by printing it or something, the first 64K will be evaluated. After that, it's just a promise for the rest of the chunks. Yeah. Lazy byte strings are kind of like lists of strict byte strings with a size of 64K. When you process a file with a lazy byte string, it will read chunk by chunk. Haven't we talked about this before? When we load files, right? We had a choice a couple of days ago, right? How to read the file. Didn't we choose chunk size? Didn't we have a memory of that? But that we didn't need byte string for that, did we? Well, Get In tab says yes, we did read about that. But we didn't need a byte string for that. But it was different. I'm trying to remember here. Right, I think we were doing something similar, but we did it not with byte strings. We did it with UTF-8, right? So every character took... Yeah, they were not byte strings because the characters were bigger. And in here, where does it say? It was 8 bits, right? For each character in byte strings, I'm pretty sure. So it's similar but different because we're using byte strings now. Right, lazy byte strings are kind of like lists of strict byte strings 64K. When you process a file with lazy byte strings, it will be read chunk by chunk. This is cool because it won't cause the memory usage to skyrocket, and the 64K probably fits neatly into your CPU's L2 cache. Right. Makes sense, I guess, yeah. Cool Get In tab says it is in the IO chapter. You can scroll off if you scroll up if you don't remember. I mean, I do remember most of it. I just don't remember the laziness, how the laziness worked within that stuff. But it's fine. I mean, we can just keep on going. If you look through the documentation for data.bytestring.lazy, you will see that it has a lot of functions that have the same names as the one from data.list. Only the type signatures have byte string instead of a list of something and word 8 instead of a in them. The functions with the same names mostly act the same as the ones that work on lists. Because the names are the same, we're going to do a qualified import in a script and then load that script into GHCI to play with byte strings. Alright, so byte strings are lists of long strings. That's what we use byte strings for. It's like data.list, but for long strings. Yes. Long strings. And we can do just byte strings are just normal, imperative. Here we go. Those are probably imperative strings, arrays, if you will, while the lazy ones creates an linked list of arrays. Right. B has a lazy byte string types and functions, whereas S has strict ones. Like that. Strict ones. We'll mostly be using the lazy version. Oh, that's too bad. I'm more interested in what's special about this one, right? Because this will pretty much just work like data.list. That's what they claimed anyway. Oh, we don't. We'll look at some specific ones. Right, the function pack has the type signature pack. All right, we have word 8s into byte strings. That means that it takes a list of bytes of type word 8 and returns a byte string. All right. I'm a little confused by word here. I assume this is a list of characters and that's a byte string character is called word 8 instead of char 8. Alright, you can think of it as taking a list which is lazy and making it less lazy so that it's lazy only at 64K intervals. A lazy list, yeah. That's the characters then. Word 8 is a character. And we pack it into byte strings. What's the deal with the word 8 type? Well, it's like int, only that it has a much smaller range, namely 0 to 255. It represents an 8-bit number, and just like int, it's in the num type class. For instance, we know that the value 5 is polymorphic in that it can act like any numeral type. Well, it can also take the type of word 8. Alright, so we can take bpack 99, 97, 110. Chunk can empty. Oh, that's the rest. The rest of the array is empty. And this is 99 is C, 97 is A, 110 is N. And it has chunk, right? This is the chunk. Yeah, can and empty. Because it's 64K big, right? As you can see, you usually don't have to worry about the word 8 too much, because the type system can make the numbers choose that type. If you try to use a big number like 336 as a word 8, it will just wrap around to 80. Oh, interesting. But of course, yeah. What we do instead, right? We pack and we unpack. Instead of actually working around with numbers, we pack and unpack if we need to, I assume. Right, we packed only a handful of values into byte strings, so they fit inside one chunk. The empty is like the empty list for lists. Unpack is the inverse function of pack. It takes a byte string and turns it into a list of bytes. From chunks, take a list of strict byte strings and converts it into a lazy byte string. Two chunks take a lazy byte string and converts it into a list of strict ones. Alright. Byte from chunks. What are we doing here? We pack these, we pack these. Oh, right. We create a byte string, another byte. Wait. Did I already? Yeah, no, it's a byte string, right? This is, we pack one byte string, we pack another byte string, and we pack a third byte string. Right, and we take it from chunks. Wow, this was confusing. All right. First chunk is this parentheses multiplication thing. From chunks, take a list of strict byte strings and converts them into a lazy byte string. Alright, so this is the structure of a... Right, this is just a list of byte strings. This here is a lazy byte string where we can do stuff with this, with this, with this. This is good if you have a lot of small strict byte strings and you want to process them efficiently without joining them into one big strict byte string in memory first. Yeah, that's the laziness. We evaluate that, we evaluate that, we evaluate that. Zoom. Alright, the byte string version of this is called cons. It takes a byte and a byte string and puts the byte at the beginning. Ah. Alright, now I understand. Yeah. It is lazy though, so it will make a new chunk even if the first chunk in the byte string isn't full. That's why it's better to use the strict version of cons. Cons with the strict thing. If you're going to be inserting a lot of bytes at the beginning of a byte string. Right. B cons, we're gonna put 85 in the beginning of this packed thing. It's a packed byte string, and we're gonna put that to the first one, right? And that we take U. Yeah, it's like U, then the colon, right? Head, tail. Right, but if we take the strict one, just get this chunk. Right. Yeah, that's the strict version. We don't create... Oh man, that is so confusing. This acts like a kind of... Well, that is linked with... The head is linked with the tail. But since this is a byte string... This is an entire This is an entire byte string. This is a data value. This is a value. Like this is a value. This value doesn't really have a head and a tail because it is a byte string. There we go. Well, get in on tabs is Lisp. Oh no! Oh no! Yeah, ran into Lisp for some reason. So it's, I'm assuming it's kind of clever in that way. Right. Fold R, where we take cons. Wait. What is this? Empty? That's a new... Is that what empty does? That it just split them all out into a linked list of characters? I'm assuming that's what we do, right? We have one data structure, but we unpack it into a linked list of word 8, right? Word 8, word 8, word 8. And it's a linked list. And here we go. Lisp. Well, tab says it makes an empty byte string. Oh, it just... Right, fold. All right, we're folding. Shit. Right, so this is our accumulator, and we start with the empty, of course, because we're folding. Still haven't practiced folding enough. Gotta start, yeah, that's something. Start practicing when we're talking about a grind every day. Doing a fold a couple of times is a good idea. Right. If we do it strictly, get this. There you go. As you can see, empty makes an empty byte string. Okay. And that, yeah, that's just our accumulator, right? The empty byte string. See the difference between cons and strict cons? Yes. With the fold right, we started with an empty byte string, and then we went over the list of numbers from the right, adding each number to the beginning of the byte string. When we used cons, we ended up with one chunk for every byte, which kind of defeats the purpose. Yeah. Yeah, exactly. It defeats the purpose because this is a linked list. This is a normal list. Sorry, what I have usually been working with. Right. Otherwise, the byte string modules have a load of functions that are analogous to those in data.list, including but not limited to head, tail, init, null, length, map, reverse, fold left, fold right, concat. I'm trying to remember. Concat, that's two lists that we join together, right? Take while, filter, etc. The only one I didn't really remember out of these. Null also I don't know. Right. They are analogous, so they will work with this. With this kind of way, I assume. Instead of this. Something tells me that they are implemented differently, because the byte string is not a linked list, so it's probably implemented differently behind the scenes, but we don't care about behind the scenes. All right. It also has functions that have the same name and behave the same as some functions found in system.io, only strings are replaced with byte strings. For instance, the readFile function in system.io has a type of readFile file path into an IO string, while the read file from the byte string modules has the type of read file path into IO byte string. Watch out, if you're using strict byte strings and you attempt to read a file, it will read it into memory at once. With lazy byte strings, it will read into neat chunks. Right. Yeah. So big files, big stuff, we use byte strings to make our program faster. That's the whole point of byte strings. I like that. Let's make a simple program that takes two file names as command line arguments and copies the first file into the second file. Note that system.directory already has a function called copyFile, but we're going to implement our own file copying function and program anyway. Right, so we import system.environment. I don't remember what system.environment did. Right, import qualified data.bytestring.lazy as b. So main do is we're gonna get arguments and we're gonna name them file name 1, file name 2. Right, we're gonna copy file name 1 into file name 2. And oh, right, I had forgotten about this. If we get our arguments, we need to not care about the rest. We only care about the first two arguments, and then people can type whatever they want and we won't throw a fit. I assume that's why we have this here. Our program won't throw a fit, I'm sorry, yeah. Right. Args, and then we copy file name 1 into file name 2. Exactly. We copy this file from that to that. This is our function then. File path, right? That's our file name 1, file name 2, and IO, we just return a nothing. We don't have anything really to return. All right, so copy file, source, and destination, exactly. So we do take contents where we take read file from the source, which is our first file name, and we write file, destination, and contents. Oh wow, that wasn't different at all. Even with the lazy stuff. It's faster for big files, but that. Right, we make our own function that takes two file paths. Remember, file path is just a synonym for a string and returns an IO action that will copy one file into another using byte string. Yeah, in the main function, we just get the arguments and call our function with them to get the IO action, which is then performed. And of course, it just copies a file to another file. Don't put something text in here. This is our root folder. Did not? Not dot. No, wait. That's gonna break, isn't it? This first brings us to home. No. It put something in our root folder. That's... I wonder, will that throw a fit if we don't run that as sudo? Probably. I mean, it's fine. You can put files wherever you like. It's your computer, but... Right, notice that a program doesn't use byte strings. That doesn't use byte strings could look just like this. The only difference is that we used b.readFile and b.writeFile instead of just readFile and writefile. Many times you can convert a program that uses normal strings to a program that uses byte strings just by doing the necessary imports and then putting the qualified module names in front of some functions. Sometimes you have to convert functions that you wrote to work on strings so they work on byte strings, but that's not hard. Yeah, exactly. So this is something you can do when the need arises, right? If you do something with large files and you notice that, well, you run your program and then you're like, what the fuck? This is taking 2 seconds. That's unacceptable. Let's spend 10 minutes and rewriting them to byte strings, and now instead of taking 2 seconds, they will just take half a second or whatever. Whenever you need better performance in a program that reads a lot of data into strings, give byte strings a try. Chances are you'll get some good performance boost with very little effort on your part. I usually write programs with using normal strings and then convert them to use byte strings if the performance is not satisfactory. That sounds great. Time is it? It's almost lunchtime. We did a little bit shorter stuff today, but I kind of feel like we're doing exceptions soon enough. Yeah, starting this today doesn't feel like exceptions is going to be a bit. I'm assuming exceptions are going to be, yeah, it's going to be the same as Python exceptions, aren't they? I assume even that Python exceptions are derived from Haskell would not surprise me. I wonder if it's the same, if you're gonna have the same attitude. It's better to ask forgiveness than permission. Maybe. I just have heard that a couple of times, but I'm assuming maybe we will get to that. But yeah, that's it for today. I'm actually gonna start having a little bit of an early lunch. So, thanks for hanging out, and yeah, have a good one. Cheers.